Hi, my name is Jaden Chahan from Next Mile Location Technology, and today we'll be hosting an informative session on LiDAR content and how it can be used to tackle transport and infrastructure planning. I'm the General Manager from Next Mile Location Technology, and I'm excited today to have on the webinar Justin White from Department of Transport and Main Roads in Queensland and Nick Preston from HERE Technologies. Justin's a principal advisor for the department and sits within the engineering and technology branch. He's tasked with building the spatial data strategy around how Queensland will design and build a world where cars drive themselves while communicating to other cars and infrastructure on the network. No small task by any means, but definitely made easier when he can rely on quality data and analysis to help guide the vision of a connected autonomous vehicle network. Also very fortunate to have Nick on the webinar as well. Nick has a decade worth of experience working in the digital mapping and location services industry, predominantly in product management roles. He's currently the product portfolio manager for the Oceania region, where he's tasked to ensure that local product strategy aligns with market requirements and customer needs. He's also driven the development of his LiDAR product from a local proof of concept to a global product. Howdy, Nick and Justin.
Well, thanks, Jaden.
So in this session, we'll provide an introduction to LiDAR technology, how it's relevant to the transport and infrastructure industries. I'll then hand it over to Justin, who will discuss applications on how Queensland TMR uses LiDAR data and the challenges and opportunities it brings. Then Nick will speak about how and why HERE is collecting LiDAR data and provide interesting use cases where LiDAR data can drive important transport and infrastructure decisions. Lastly, we'll have a Q&A session where I'll ask Justin and Nick some commonly asked questions. So just before I begin with the LiDAR discussion, I just want to briefly discuss who Next Mile is and what services we provide. Next Mile Location Technology is an organization that understands that spatial data is constantly changing, and it is complex to capture, store, and analyze real-world information in order to make data-driven business decisions. That's why we've partnered with HERE Technologies as they simplify this process. Next Mile has been set up to be HERE Technologies distributor for the Australian and New Zealand region, and our main services are to drive market adoption and awareness of HERE content and technologies, on-sell and license their APIs and content, provide technical support and guidance, help design and build applications or integrate systems that use HERE APIs and content, and lastly, transform HERE data so that it can be easily integrated into your data pipeline. All right, let's talk about LiDAR. What is it? Why is it used? LiDAR stands for Light Detection and Ranging and is a non-contact, non-destructive technology that digitally captures the shape and dimensions of structures and objects using a line of sight laser. It uses a very rapid laser beam of up to 2 million points per second that scans the environment and captures a vast quantity of data from the surface of structures and objects in the form of a point cloud. Each point has its own X, Y, Z coordinate and is fixed to a global reference system. In other words, LiDAR is a way to capture a structure or object's exact size and shape and represent this in a 3D model or a digital twin. So LiDAR can be captured in a few different ways. Each capture method has its own pros and cons and serves best depending on the outcome required. For example, vehicle captured LiDAR is ideal for road level object detection and measurement, such as road furniture, lights, street signs, and because it's captured from the road level, it can detect a level of detail that cannot be captured from the air. Airborne capture, however, is used by planes and drones and is mainly used when wanting to capture large areas of land and can measure things like tree canopies, terrain slopes, vegetation densities, floodplains, or building heights and structures. Bathymetric capture is also super interesting because it measures the depths of the seabed surfaces and structure, heavily utilized around seaports and ferry wharves to measure water depth. And lastly, most commonly known, mobile laser capture, typically used around construction sites where the purpose is capturing 3D point data around a building or a structure. LiDAR plays a massive role in how governments and planners design and build infrastructure. For example, in built environment simulations and infrastructure justification processes, planners can use LiDAR to enhance precision of their 3D visualizations or test design models or concepts. LiDAR can be used to conduct remote measurements on assets, such as bridges or buildings, or perform shadow and line of sight analysis on an area. In heavy vehicle planning, engineers can use LiDAR to understand the impacts of freight movements across regional or metropolitan road corridors to ultimately optimize delivery routes for heavy vehicles. During a telco network rollout, engineers can locate ideal positions of cell towers and measure line of sight to optimize signal strength and coverage. And for monitoring of road safety, road planners can visualize and measure road curvature and camber, detect road signs, or even measure distances of objects like trees or telegraph poles to the edge of the road, ultimately to reduce road risk ratings. It's also quite noticeable that in the automotive industry, they're pushing towards an electrification of self-driving vehicles. LiDAR plays an instrumental component with autonomous driving technology. Just like humans rely on their eyes to drive, LiDAR is the eye of the car. Coupled with a powerful computer, it can detect moving and stationary objects in front and around the car hundreds of times a second. It is then used to measure and calculate distances from objects and processes this information to navigate from A to B. The future is when vehicles are autonomous and they communicate to other vehicles and infrastructure on the road. LiDAR is critical during the infrastructure design phase as it enables engineers and transport planners to test and simulate a digital twin that reflects all aspects of the road, such as elevation, curvature, road roughness, and then major infrastructure structures like height and widths of tunnels, toll booths, and road barriers. And then simulate traffic conditions during peak and non-peak periods, guiding how traffic systems should operate to achieve greater throughput of passenger volumes. LiDAR also plays an important part in autonomous vehicles, feeding data to the car's central computer system so that it can safely and efficiently navigate around other cars, road users, pedestrians, and its destination. LiDAR enables better decision-making for infrastructure design and navigation of autonomous vehicles. So next, I want to give the mic to Justin from Queensland TMR, and he'll discuss how the department uses LiDAR data and the challenges and opportunities it brings. Over to you, Justin.
Yeah, thanks, Jeetan. And hello, everyone who's taken the time to listen. Thank you for listening. So here at Transport and Main Roads, we've been using LiDAR for many years, and we use aerial as well as terrestrial LiDAR for a variety of use cases. Primarily, though, we use mobile laser scanning, and we have done for almost 10 years now. The main use for MLS is for detailed design data. So we get highly accurate multi-pass LiDAR to form the basis of our designs for new infrastructure and for changes to existing infrastructure. And once we've finalized the projects, we also are beginning to use mobile laser scanning more and more for as-built captures as well, where we document the infrastructure as it is now, as opposed to the design that originally went in at the other end. So a secondary output from that has been that we also capture assets in some areas where we can capture things like the signage, the posts, poles, lights, all that kind of all those kinds of assets around the network. But generally speaking, that's only for a small part of the network, and only in parts where we've collected the LiDAR for some other purpose. So we've also more recently done some single pass mobile laser scanning. So it's less accurate in terms of absolute accuracy, but still very accurate within the scan itself. So points within the scan, distances between them is very accurate. So we use that for assessing routes for oversized heavy vehicles. So basically creating an envelope through which a vehicle could travel along a route, depending on the size of the vehicle and the features it would hit along the way. And that also allows us to identify movable features, such as trimming back some trees versus things that aren't so movable, like a building, for instance. So that allows us to then plan for those ridiculously oversized vehicles that go out to the mines on occasion. Generally speaking, our airborne LiDAR we use for route assessment in early planning, and also flood modelling, slope assessment, some noise modelling, anything that doesn't require high detail, but still requires pretty good elevation information, and is required over a larger area. So the broad scale of airborne LiDAR allows us to do that. And then we also have a static terrestrial LiDAR capability in-house, and we use that for the hard to reach places such as under bridges or inside bridges, and in areas that are damaged by natural disasters. So that gets a reasonable amount of use as well. So in terms of challenges, just the sheer volume of data, the raw data, presents a challenge to us in managing that, analysing it and extracting the useful information from it. Most of our data procurement in terms of LiDAR is through third parties. So we have the usual delays in procurement, not only in getting the data from a third party, but also just going out to market can take months. And then there's the data extraction, and whilst we use it for things such as design, there are lots of opportunities, and we aren't necessarily always in a place to do that data extraction ourselves. So sometimes we don't even know what we want, which can be problematic. And then managing the data consistency and maintaining timely data is a challenge for us going forward as well, especially seeing as we're getting data from a variety of suppliers. In terms of future uses, we're really keen to make more use of LiDAR and extracting information across our network instead of in such a narrow focus of project to project. So looking at more broad scale usage and adding other use cases. So there's any number of safety use cases we could look at. Asset inventory is a major ongoing issue for transport operators everywhere, where knowing where all your assets are and in what state they are in. Vegetation and hazard detection, so identifying hazards within the distance of the road and whether or not our barriers are appropriate for those hazards, and checking that the barriers actually comply with standards as standards change. So another area that we could use it for is around bridge clearance heights and ensuring that those are maintained and up to date, especially given any changes to the road network that occur. Every time you redo the road surfacing, it can change those heights as well. So LiDAR has been and continues to be very important to TMR's operations. and it's only going to get more so. We have quite a few challenges in terms of getting the most value from the investment, but we do understand that there is much more value we should be extracting, and we are working towards doing that. So back to you, Jeetan.
Thank you. Very fascinating. I find it interesting on the number of different types of laser capture that you guys have. So I got single pass, terrestrial, airborne, mobile. It's quite a handful. Thank you, Justin. So next, I've got Nick from Here Technologies wanting to talk about their offering in this space. Over to you, Nick.
Thank you, Jeetan, and thanks for the introduction into LiDAR, and Justin, thanks to you for providing that perspective from TMR and how you guys are using LiDAR and find value from it. So today I'm going to talk on behalf of Here and talk a little bit about the new LiDAR data product that Here has launched. Also, why we believe that how this product will add value and really address some of those common challenges that people find when dealing with LiDAR, and really lowering the barrier of entry to using this type of data more broadly. So I'm just going to start off with a quick introduction into Here Technologies, and for those who aren't familiar with us, we're a location data and platform organization with a long history in the automotive industry, supplying map data for in-vehicle turn-by-turn navigation. While automotive is our legacy, we're now working across multiple industry segments, including transport logistics, the likes of planning, optimization, navigation, analytics, at different levels of government, both here in Australia and around the world, and more recently, starting to do some more work in the telco and also insurance spaces. So while the location services and the platform solutions help to deliver more support and value to our customers, it's the building and maintaining a portfolio of high quality data products, which is really key to the health of our business, and still where many of our customers differentiate us from the competition. And this is why Here Technologies continues to invest heavily in data capture to ensure that we can build and maintain these data products for an ever-changing built environment. And today, the focus of my presentation is going to be on this capture technology and how LiDAR forms a key component of that. So next slide, please, Jeetan. So as Jeetan said in his introduction, LiDAR can be captured in a series of different ways, and that can be from a aerial capture, from a drone, a tripod, a backpack. All of the data which Here captures is mobile laser scan data, or MLS, as Justin touched on. And for us, the reason why we capture it in this way is that it provides the appropriate perspective and also the level of detail at street level that we require to build our products. So this slide shows the capture technology and each of the components that make it up. So there's four key parts of this. We have the Velodyne LiDAR with a capture rate of 700,000 points per second. It's angled on top of the mast to collect the highest density of data on the road surface. Then we have the 4 20-megapixel cameras, which provide full 360-degree view around the vehicle, a differential GPS, and also an IMU, or an inertial measurement unit, to help maintain the accurate positioning in areas of low satellite reception. So Here has a large fleet of these collection vehicles all around the world, all with the exact same hardware And also all of this data is processed in the same way, which means that wherever we collect and process this LiDAR data, it's a consistent output regardless of when it was captured, or also where in the world it was captured. Next slide, please, Jean. So this animation on the screen gives you a sense of how that data is captured and the range of the LiDAR from the vehicle. You can see that all of the roads, the road furniture, and the surrounding buildings are captured in incredibly high detail. Like I mentioned before, the density of points is the highest at the road surface, and you'll notice that will decrease. The density of those points will decrease as you get further away from the vehicle and start extending beyond about 5 to 6 stories of those tall buildings. Important to note that while this video does show the uncolored data, the product or the data which Here Technologies is providing is actually colored, and you'll see that in an example in a couple of slides. Next slide, please. So I just wanted to spend a couple of minutes talking about how Here Technologies is already leveraging this LiDAR data and how we are consuming it for our own internal products. And you can see on this slide that we have a suite of products which rely on the capture, freshness, and accuracy of mobile laser scan data. Each of these products have been designed to support very specific use cases, which Here has identified and leverages our MLS data all in slightly different ways. The first product that I want to highlight is the HD map, and really this marks a shift in the level of accuracy and detail in mapping data to support highly and fully autonomous vehicles. We're leveraging the point cloud data to extract the boundaries for the road and lanes, the surrounding road furniture, to allow vehicles to position themselves accurately on the road. So this product really allows these semi or fully autonomous vehicles to understand exactly where they are, where they're going, and how to get there by following the road rules and get there safely. This is a very automotive focused product and designed to be consumed as a service and updated frequently to deliver the freshest data. Next, we have our 3D city models, and as the name suggests, these provide models and objects for a number of metro areas around the world. They have customizable levels of detail with buildings, roads, and land use features which sit on top of a high resolution digital terrain model. So our existing repository of street level LiDAR allows us to accurately model and position these features. And then this data is supplemented with aerial capture to fill in the gaps. So the tops of the buildings or the areas that aren't visible from the road. The last example I want to highlight as a Here product is our geodata models, and this is specifically targeting the challenges which surround the rollout of 5G networks. So similar to the 3D city models, we derive an accurate digital terrain model and align the building models, but the geodata product provides additional objects such as trees and poles, which are really relevant in the planning of these new networks, which will require many more cell sites than your typical 3G and 4G networks. So again, as Jeetan touched on before, this is where a very accurate model of the built environment or a digital twin can enable things like at the suitable positioning of these cell sites and also support line of sight analysis. So While Here Technologies leverages this LiDAR data to build products for quite specific use cases, we recognize that a number of use cases and really the value of this data can extend further by supplying the raw material that we collect. And this is why we've made the decision to launch the LiDAR data product, which taps into this existing resource that we've been collecting over the years. Next slide, please. So this is a short video which visualizes a small section of our LiDAR data extracted through the Here platform and loaded into a simple point cloud viewer. This is a typical look at the quality and the completeness of the data, which you can see is colored using the Here collected street level imagery. So just to highlight some of the features or use cases which this data can serve, we can see that the nature of this data captures an incredibly accurate surface model and can enable you to model any changes of those elevation, slopes or curvature in the road, differences between different grade crossing of roads. We see the details within the road, such as the lanes, the types of lane markings, be it a merge or an ending lane, can be identified, they can be measured. These are all sorts of things that can play into road safety analysis. The surrounding road furniture, such as guardrails, signs, poles, trees, their positions and volumes can all be measured and collected. This data, being able to analyze it in 3D in this way, gives you the ability to understand the relative positions of all of those features as well that surround the road. So you can see from this video, we're able to take measurements of the road. So this could be the entire road surface, the distance between lanes, also the measurements of from the road to the bottoms of bridges. Again, that this can play into that clearance or low bridge analysis for oversized vehicles. Also, having a live and interactive 3D environment, it can play into other things such as line of sight at different positions on the road. The nice thing about all of this analysis is that it can be completed from the desktop. So the time between actually requesting this data or identifying the area of data which is needed, requesting that data and receiving it to be able to view in 3D like this, depending on the size, can be within a day or in a matter of days if it's a larger area. Next slide, please, Cheaton. One of the real value points of the Here LiDAR data set is the existing coverage that we have for the product. We've been collecting LiDAR data since 2014 here in Australia and in most other countries around the world, which means that we've been able to build up an extensive library of LiDAR data, which is now accessible on demand. So this is a look at the LiDAR data coverage in Australia and New Zealand, which you can see is comprehensive. All of the major metro areas have been covered down to the residential street. And nationally, we've included all the motorways, freeways, and arterials, and really any road that provides connectivity within the regional towns or even the smaller population centres. So to date, we have covered roughly 400,000 unique kilometres of road in Australia, Many of those roads will have been collected a series of times since we started the collection back in 2014. Really, the major gaps in our coverage exist on your rural, unpaved or typically four-wheel drive tracks, and actually the surface of those roads provides its own challenges for collecting this sort of data with the equipment that we have. So, you know, naturally each product, each project which is being completed will have its own different data requirements in terms of coverage or freshness. So, you know, if there are any specific questions around areas or the age of those areas, then, you know, please reach out through Next Mile, and you know, more information can be provided as needed. So next slide, please, Jeetan. So this is my final slide, and really just to wrap up this section and provide a summary. I'd like to emphasize that it's not necessarily the LiDAR data itself which makes HERE's offering different. There are already a number of different groups who are collecting street level data. Really, it's the scale of HERE's existing repository, which allows us to deliver large amounts of high quality data in a short time frame. It's also the on-demand clip and ship nature of the portal, the data request portal that we've developed, which allows users to just request and pay for the data that they need when they need it. And so this really addresses some of the common problems with handling LiDAR data, because it keeps the cost of acquisition down, but also how that data is managed, be it, you know, sharing within a department, or even just storing all of that data. Some of the things that Justin touched on in his presentation. And just to reinforce that, you know, we are a global operation, and the equipment that we do have on our fleet is consistent. So if that data is being requested here in Australia or New Zealand or in other parts of the world, there is a consistency of capture and output of that data. So hopefully that provides a bit of an introduction into HERE Technologies, our history of data collection with LiDAR, and some of the industry challenges that we're hoping to support with this new product offering. Thanks, Jeetan.
Amazing. Thank you, Nick, for that presentation. Really, yeah, it's just the amount of data that you guys have collected over the years is mind-boggling, and the detail that you have as well. Just I haven't seen that at such a big, large scale before. So thank you, Nick. So now we're just going to do a Q&A session. I've got a couple of questions that I want to ask Justin and Nick about, the hard questions that we're all wanting to hear. So, no, I'm just joking. So I've got some nice questions to ask. I'll start with you, Justin. How does LiDAR help inform transport planners design a road network suitable for autonomous vehicles? So, where do you start?
Yeah, look, I guess one of the critical things for autonomous vehicles from the government perspective is that autonomous vehicles, in order to gain the benefit that we all expect, also need to be connected vehicles. So if they're not connected, if they don't know what else is going on in the network, if they don't know what else is going on with other vehicles, then they're nowhere near as efficient, and we don't get the benefits that we would like to see through those vehicles. So I guess in order to support connected vehicles and therefore connected autonomous vehicles, we need to know more about our network, and we need to know timely data about our network at all times. So I guess the data that traditionally road authorities have is really around asset management at the moment. And asset management data has a different timeliness requirement, I guess you'd say, and also accuracy requirement. And as long as you can find the thing, you don't really need it to be that accurate. But the more we get into the connected autonomous vehicle space, the higher level of accuracy is required, and also the ability to get timely information and have regular updates in areas where you need that, particularly the places that are changing constantly. You know, in Queensland, you're talking out Springfield or the Gold Coast or the Sunshine Coast, where there's new developments and, you know, hundreds of houses springing up every month, new roads, new infrastructure, constantly changing speed limits. You know, they'll build a beautiful road that's bi-directional, and in a couple of months' time they'll build the second one next to it, so that now you've got a divided road that's one way each direction, and it was 70 kilometers an hour and now it's 80 kilometers an hour. So it's all that. How do we get that information? And LiDAR is one of the tools that we have at our disposal to be able to quickly collect and extract and use that information. So it also helps us with understanding the you know, automated vehicles use LiDAR, so we need to be able to ensure that our roads are supportive of that, so that the automated vehicles can run on our roads, and the infrastructure we have in place will support that. So again, it allows us to see what is visible and what a LiDAR can do on our road.
Very interesting. Yeah, it makes sense. You have a common data platform. You build the infrastructure with a common data set that is also used by autonomous vehicles making decisions on the fly. Yep. That makes sense. I've got a leading question then from that. What tools or software does TMR use to extract this information, like from LiDAR data?
So predominantly TMR goes out to market, right, for the products that we want in this space. So we generally go out to market, but we also get the point cloud as part of our deliverables. So we use Euclidean geoverse tools and Euclidean software for visualization as well, and LAS tools for our point cloud stuff mainly. And then we also, of course, bring most things into 12D because that's our design platform. So that's basically how we make use of the data. There is we're looking at what options we have going forward for automating a lot more of the capture, because at the moment things are manual, things are very much done by hand. So
fair enough. I will switch over to Nick. So aside from the products mentioned in your slides, are there any other information derived from his LiDAR content that you use to build or enhance other products?
Yeah, sure. Thanks, Cheaton. So, I mean, fundamentally, Here Technologies is a mapping company, and so when we build all of these, all of our map data products, like when we digitize new roads. So when Justin gave that example, making sure all of those roads are in our database, make sure they're accurately aligned, and making sure all of those roads have the adequate attributes so that they can they can serve different use cases. Making sure the road is named accurately, the direction of travel is accurate, and the speed limit. So that is fundamentally our core business, to build that map, and so there's a series of data points that we can capture from the LiDAR data, which I guess reinforces or helps us to validate and apply some of that detailed attribution. So I guess in the transport space, one of the valuable products within our portfolio is the trucking product. For those drivers, making sure that their vehicles don't come in contact with a low bridge or overhanging physical structure is key. It ensures the safety of the driver and also the valuable asset that they're driving, and also the public infrastructure. So for us, being able to accurately validate from the desktop what the height of that bridge is, and to ensure that it does meet, it does align with what the sign says, or if there is no signage in reality, how we can appropriately attribute that low bridge or structure. Aside from the 3D products that we produce, what LiDAR data does really well is it enables you to position things in 3D space, and so that means that where we have certain attributions or the positions of certain features which affect different use cases, being able to apply those attributes accurately to the underlying map data is really important to us.
Oh, very interesting. So I remember you saying that you started the capture back in 2014. Can customers get access to that from 2014 onwards, and how often is it refreshed?
Sure. So what we're offering through the data request portal at the moment is access to the freshest data available. We recognize that through the product development and launch process, there is I guess there's a need within the market to be able to go back in time and look at those historical data sets. So currently what we're offering is just the freshest available, but it is now on the roadmap to be able to go back and analyze and potentially compare or look at those different historical data sets at different points in time. In terms of the refresh of our data, I would say it varies based on a number of things. Predominantly, our focus is on the highest, I guess, the highest traffic roads, which means that all of your national highways and freeways get updated most frequently. These are the roads that support the majority of the traffic here in Australia and elsewhere. From there, we're prioritizing those major metropolitan regions, and also the regions that we've identified as high change or high level of development. So for us, we want to ensure that we are capturing all of those changes which exist on the road network as close to real time as possible. So that tends to dictate how we prioritize our fleet. Ideally, we would drive every road every year, but with the resources that we have, we do look to prioritize those areas of highest change.
Makes sense. At least though, you've captured the regional areas, which don't change that often, but it is available. And the metro areas that are constantly changing, that's the stuff that you're capturing along the way as well.
Yeah, that's absolutely right. So we've invested heavily within the last couple of years to extend that coverage beyond just the metro areas, start to incorporate some of those more regional towns and population centers, as well as all of the connective, the those roads that provide connectivity, and that be that state managed or both state managed and council managed roads.
Fair enough. All right, last question for Justin. So you mentioned that there are a number of different types of LiDAR captured content provided. How do you maintain consistency and quality from all the different flavors of LiDAR that you capture?
Sorry, yes, that is a challenge, Jeetan. I guess it's not just the different flavors, it's also the different providers as well. So we see the mobile laser scanning and increasingly now aerial LiDAR as well coming in from third parties. And to manage that, we have a guideline for mobile laser scanning, and that goes into quite a bit of detail about the outputs that we expect and the standards that need to be followed, and the products that we want to see and in what format. So, for instance, our point cloud must come in as LAS 1.2 format. There's a naming convention, layout convention that must be followed. The ground and feature models and reference frame have to come in 12D format. We have quality assurance requirements, survey report, and all of that, so that we can have confidence in the product that we're getting. And also, we don't have the same level of detail yet for our airborne LiDAR, but we've modified the same thing for aerial LiDAR capture as well. And it's still a challenge, obviously, to ensure that everyone is following the same standards and that the quality is there. As the industry is maturing, it's getting a bit easier, but certainly in years past, when some of the newer players weren't used to the quality requirements that we put on them, which is really quite high in terms of accuracy and quality. So we did have a few issues, but we're not seeing those issues come through so much now. But yeah, I mean, we put a lot of effort and a lot of time into ensuring quality and consistency of the data.
Interesting. All right, thank you so much, Justin and Nick, for your time. We're going to wrap up this session. It was so interesting just to understand, Justin, from a government's point of view, the value of LiDAR data it has in making better decisions for infrastructure and transport planning. And also, Nick, from his perspective, the amount of investment that here is making in order to create a HD map, which then provides a lot of detail around how it maps the digital world. Super interesting. So thank you very much, both gents, for your time. And if anyone has any information or requires any information, please reach out to me on my email address or phone number. Very happy to answer your questions and link you up to these two gentlemen if required as well. Thank you, and have a great day.
Thank you.